Language models have been shown to exhibit biases and stereotypes. So for this, people have proposed bias mitigation methods, but how do these bias mitigation methods actually affect downstream tasks?
Hi, I'm Ewoe and I.
And I'm Peter Dullebelle.
And we are going to present our work, How Far Can It Go, on intrinsic gender bias mitigation for text classification.
Language models, like BERT, are typically trained in two stages, so also on two datasets. The pre-training step, typically on larger unlabeled datasets, and then the fine-tuning step, with smaller but labeled corpora. We typically use an already pre-trained model, like BERT base, to do some other downstream tasks, such as sentiment analysis. Each training step and its datasets can introduce bias, which we refer to as intrinsic and extrinsic bias. So there are some symmetries between the pre-training and the fine-tuning. Both get a dataset and you train first your language model on it, and then finally you do fine-tuning on the fine-tuning dataset. And with both of them, you can counteract biases in those language models by introducing a counterfactual data augmentation or otherwise debiased corpus. And that works for both pre-training and fine-tuning. And what you can also do is debias the language model after pre-training or after fine-tuning as well. And in both cases, then you also end up with a fine-tuned or pre-trained debiased language model. And what we look at in our paper is if you start from a debiased language model, but then fine-tune it on a normal, possibly biased corpus for fine-tuning, what you end up then is still just regular fine-tuned model that might be biased. But if you also debias or fine-tune it on a debiased corpus, then you end up with a debiased fine-tuned model, only that combination.
It's still unclear what the relationship between intrinsic bias mitigation techniques and extrinsic bias is. And based on that, we would want to answer three main research questions in our presentation. So in the first question, we would want to look at if different intrinsic bias metric respond differently to different bias mitigation techniques. By this, what we mean is whether improvements by different intrinsic bias mitigation techniques are equally detectable by different measuring techniques, or whether some measuring techniques are more sensitive or overfit different mitigation techniques for intrinsic bias. Secondly, we also want to see whether intrinsic bias mitigation techniques can hide or resolve bias. In previous works which have explored non-contextualized word embeddings, there has been significant evidence that some mitigation techniques in that context do not actually resolve bias but just mask the bias. We want to see if this is equally the case in contextualized language models. Thirdly, we want to see if intrinsic bias mitigation techniques in language models improve fairness in downstream tasks. Since the end use of these models is in real-world applications, which are often fine-tuned on downstream data, we want to see if the actual benefits of mitigating bias in the intrinsic model applies. Now we'll discuss our setup and some definitional terms regarding our presentation. So the first we'll look at is bias, and we define bias as the undesired variation of the association of certain words in that language model according to certain prior words in a given domain. Secondly, we would look at our notion of bias, and in this context would narrow our definition to gender and specifically look at binary definitions of gender. So with bias, there are two concepts we would like to introduce. The first is stereotype terms or target terms. And by this, we refer to professions or words that are supposed to be gender neutral but have been associated with certain gender groups over the years. We'd also look at attribute terms or gender terms, and these refer to actual gender words. So for example, we look at gender pronouns such as she and he. Next, we look at the setting of language models we use, and in all our experiments we used the BERT large language model and the Albert large language model. And finally, we would also look at the data set, and all our experiments were done in the English language setting, and for that we use the bias in BIOS data set and the Jigsaw data set.
Before we get started, we first need to understand how we can measure and mitigate biases in language models. And this is not trivial. So if we start by looking at intrinsic bias mitigation and intrinsic measuring techniques, we see that there are a few options already. So to mitigate biases in language models intrinsically, so with the pre-training, we can do counterfactual data augmentation during training, or we can try to debias it by in-processing, or as we explained before, by post-processing. And then to measure intrinsic biases, there are quite a lot of options. And here we try to focus on two options. So first, the sentence embedding association test, or SEAT for short, which basically tries to measure if there are associations between words of a specific gender. For instance, housemaker and women and computer programmer and men. But this is then contextualized, so for language models. And then you also have the log probability bias score, and that one tries to measure how likely a word is in its context. So for extrinsic bias mitigation techniques, we do have quite some parallel approaches. So, for example, we have attribute swapping, which is also a CDA approach. And then there's also attribute scrubbing. And then to measure extrinsic biases, we basically have our binary classification metrics that we know from the classic fairness literature. So the true positive rate difference we looked at, and we also used counterfactual fairness. So the first research question we asked ourselves is if intrinsic bias metrics respond differently to bias mitigation techniques. And apparently they do. So if we look at BERT and Albert and we evaluate different debiasing methods with both SEAT and the log probability bias score, then we see that there are some differences. For example, if we look at context debias, there we have a very low score for SEAT for both language models, but the opposite is true for scent debias. There we have a low bias score for the log probability bias score. So then we can conclude that indeed there are differences between bias metrics and they respond differently to these different mitigation techniques.
So for the second research question, we would want to see if intrinsic bias techniques actually mask bias instead of resolving them. To do this, we first obtain a text corpora from different sources, which include the Yelp dataset and the Reddit dataset. Based on a list of gender word lists and a list of stereotypes, we extract sentences from the corpora. We then pass these sentences through the pre-trained language models and its debiased versions to obtain embeddings corresponding to these language models for the sentences we obtained. The gender word or embeddings from gender words are then used to train a gender classifier to detect the association of words to certain gender groups. Or we use this trained classifier to evaluate gender or detect the presence of gender in stereotype words. And we do this detection using two criteria. So we use the accuracy of predictions and confidence. What we found from our probe in relation to the standard metrics we used earlier was that some of the mitigation techniques can indeed hide bias instead of resolving this. And what we mean is that using the probe, we're able to uncover bias to very significant levels, almost to the extent of the pre-trained levels in debiasing techniques such as scent debias for both Albert Large and the BERT large language models. And this shows that even though certain models or certain evaluation metrics such as log probability bias score tell us bias drops significantly when mitigated using scent debias, these biases can still be uncovered to a high level of accuracy. However, we note that the confidence of these predictions drop, which shows that when it comes to the probability of predictions, the model actually struggles when all debiasing techniques are applied. But we can, again, to a high level of accuracy, uncover these biases. In answering our third research question is where we actually want to see the impact of intrinsic bias mitigation techniques on downstream tasks in natural language processing. To look at this, we use our data sets, which is the bias in BIOS or the jigsaw data set, and look at how the various intrinsic mitigation techniques perform in the context of various downstream interventions. So for the downstream interventions, we have the original data set, we have the scrubbed version of it, and we have the swap version, which we also call the CDA version of the data set. We then pass these through the debiased models, and we evaluate these versions using our two metrics we introduced earlier, which are the counterfactual fairness and the true positive rate difference. The results of our experiments, we highlight the intrinsic models on the vertical axis and extrinsic interventions on the horizontal axis. And we realized for true positive rate difference, we realized the intrinsic interventions do not significantly improve fairness. We see that the improvements we chalk actually come from the extrinsic interventions, which leads us to the conclusion that mitigating bias using intrinsic interventions does not significantly improve on fairness when downstream fairness is the goal. If we look at in the case of counterfactual fairness, we realize the results are the same, except for the fact that cent debias improves counterfactual fairness scores. And we postulate that this is because cent debias, based on its mode of application in downstream tasks, behaves more like an extrinsic intervention.
So that brings us to the conclusion. We developed a probe in our paper to investigate intrinsic bias in two language models, and we found firstly that intrinsic bias metrics can be sensitive to certain bias mitigation techniques. Secondly, we found that these techniques are capable of concealing bias instead of actually resolving it. And thirdly, that these techniques actually do not consider fairness on downstream tasks, so in text classification without any further fairness interventions on the downstream task itself. So our recommendation is that intrinsic bias mitigation should be combined. We ideally want it to be combined with other fairness interventions on the downstream task. And when you do bias mitigation, you should also evaluate it with multiple metrics to make sure you're not believing only one metric that says it's unbiased, even though there might still be biases present in your data. So that's it for our paper. If you liked it, you can find more information online or read the paper as well, and feel free to follow us or reach out.